Here are the solutions to exam 2. Question 1, find the derivative of each of the following. So for this first one, it's a simple power rule on each one of these. 7 times 3 is 21, lower the power by 1. 9 times 2 is 18, lower the power by 1. The derivative of 15x is 15, of course that's negative. The derivative of 16 is 0. Question B, this one is a product rule. We have the f and the g. The f is x to the 7th, the g is e to the x. So the derivative is the derivative of f, so 7x to the 6th, times g unchanged, so e to the x, plus the derivative of g, the derivative of e to the x is e to the x, times the first one unchanged, so times x to the 7th. C is a quotient rule, so we have y prime is equal to the derivative of the top, so that would be 5x to the 4th plus 4 times the bottom unchanged, so 3x cubed plus 10x squared minus 19, minus the derivative of the bottom would be 9x squared plus 20x times the numerator unchanged, so x to the 5th plus 4x minus 9, divided by the bottom squared. Question D is a product rule. So we're going to have an f and a g. So y prime is the derivative of f. That is 8 to the x power. And the derivative of 8 to the x power is 8 to the x power times the natural log of 8. All of that right there is simply the derivative of f. Then times the g unchanged, so x to the 8th, plus the derivative of x to the 8th, so it's 8 times 7 to the x, times the first one unchanged, so 8 to the x power. Part E, y is equal to e to the x squared minus 1 power. We need to use the chain rule on this. So this is y prime is equal to e to the x squared minus 1 times the derivative of the exponent, which is 2x. Next page. Part F, the derivative of the natural log of x to the 4th minus x to the 5th. So the derivative of natural log functions are 1 over, and then we're going to take the inside, so it's x to the 4th minus x to the 5th, times the derivative of that inside, which is 4x cubed minus 5x to the 4th. And of course you could have written that in the numerator if you had wanted to, no problem. Part G, y is equal to log base 5 of 3x. That derivative is 1 over the argument, 3x, times the natural log of the base of the log, and that's 5, times the derivative of the inside. The derivative of 3x is 3, and of course if you were asked to simplify this, you could cancel those 3's. H is a quotient rule. So this is y prime is equal to the derivative of the numerator. And you have to be careful because in the second part of the numerator, it's not e to the x, it's e to the negative x. So here we're going to have the derivative of that first part of the numerator, e to the x, plus the derivative of e to the negative x, which is e to the negative x times the derivative of that exponent, and the derivative of negative x is negative 1, times the bottom unchanged, minus the derivative of the bottom, e to the x, minus e to the negative x times negative 1, times the numerator unchanged, all divided by the bottom oops, the bottom should be a minus, squared. Part I is the derivative of the natural log of x squared times the square root of x squared plus 1. So here we're going to use the natural log derivative, but we're also going to have to use the chain rule to take the derivative of the inside, and the inside happens to be a product, so we have to use the product rule as well. So, first things first, the derivative of the natural log is 1 over, and then it's the argument of the log. Now times the derivative of the inside. The inside is a product, so we're going to have an f and a g. The derivative of f is 2x times g unchanged plus the derivative of g. Now g is another composition and requires a chain rule on its own, because it's the derivative of the square root function, which is 1 over 2 square roots of, and then the inside stays the same, multiplied by the derivative of the inside, so it's the derivative of this x squared plus 1, and then you take that and multiply it by the original f, which is x squared. And that is the complete derivative. Notice how these get a little harder as you go through the test here. All right, then lastly, question J, you want to find y prime when you have the relation y cubed is equal to e to the y plus x squared. So let's take the derivative on the left. That would be 3y squared, and since you took the derivative of y, you multiply by y prime, based on the chain rule, is equal to the derivative of e to the y. Well, the derivative of e to the y is e to the y, but here you need to take the derivative of the exponent. The exponent is y, so that derivative is 1 times y prime, plus the derivative of x squared, which is 2x. Now the key to solving an equation like this is to isolate the y primes on one side and then factor that out and divide. So I'm going to move the part with the e to the left. So we now have 3y squared times y prime minus e to the y times y prime is equal to 2x. I'm going to factor out the y prime. And then divide by that new coefficient. So y prime is 2x over 3y squared minus e to the y. Let's look at question 2. Let f of x equal x cubed plus 2x. It says find all values of x where the slope of the tangent line of f is equal to 77. So we know that the function that gives me the slope of the tangent line is the derivative. So let me go ahead and compute that. That's 3x squared plus 2. And now I want to know when this is equal to 77. So I'm going to set it equal to 77 and then solve for x. So we get 3x squared is equal to 75. Divide by 3, you get x squared is equal to 25, and then take the square root, and you get plus or minus 5. So plus or minus 5 is the values of x that'll give me a slope of the tangent line equal to 77. Question B. Show that this f does not have any horizontal tangent lines. Well, if it did have horizontal tangent lines, then that would be the derivative equal to 0, which is 3x squared plus 2 equals 0. If I try to solve this, I get 3x squared equals negative 2, and then x squared is equal to negative 2/3. And we know that this type of equation has no solution because you can't square x and end up with a negative. Again, remember we're not using imaginary numbers in this course. Question 3. How much should be invested now at 6.15% compounded continuously so that you will have $10,000 after 3 years, and assume no other deposits are made into the account? So you need the PERT formula. A is equal to PE to the RT. The amount that we want total is $10,000. We're looking for the principal to invest. E to the 0.0615, and we're going to go for 3 years. And by the way, we know that we want the PERT formula instead of the regular compound interest formula because of the continuously compounded interest keyword here. And so then P is equal to 10,000 divided by E to the 0.0615 times 3, and you work that out and you get $8,315.20. Question 4. Use differentials to approximate the value of the square root of 173. So first thing is we want to describe our function, and that is the square root function. We want to pick a value that we know the perfect square root of, which is 169, and from that we come up with delta x, which is how far away the new number is from our base number here. So 173 is 4 away from 169. Next, we need the derivative. The derivative square root function is 1 over 2 square roots of x. We need the differential formula, which is dy is equal to f prime of x times dx. Now remember, when we do a differential problem, we assume that dx is equal to delta x. So that's going to be equal to 4. So here we're going to have 1 over 2 square roots of 169 times 4. And if you work that out to decimals, you get 0.15385. And then that tells me that the square root of 163 is approximately the square root of 169 plus my dy, which gives me 13 plus 0.15385, which is 13.15385. Remember, the goal here is to use differentials to approximate a value, not to find the actual value. Question 5. The sides of a square are increased from 8 centimeters to 8.2 centimeters. Question A. Find the exact change in area of the square. So exact change is delta A, and that would be the second side of the square squared minus the first side of the square squared, because the area for the formula for the area of a square is x squared. So this is just 8.2 squared minus 8 squared, which is 3.24 square centimeters. B, use differentials to approximate the change in area of the square. So dA is equal to A prime times dx. So A prime is the derivative of the area function, which is dx, 2x rather, and then we multiply that by dx. And so we're going to get 2 times, and you start with what the square started as. It started as 8 centimeters, so you're going to use that as the basis. And then how much did it go up? Well, delta x is 8.2 minus 8, which is 0.2. And when you do a differential problem, you assume that dx is equal to delta x, so it's 0.2. You work that out, and you get 3.2 square centimeters. Now these, of course, should be close to each other, relatively speaking, and they are. Let's look at question 6. A company produces coffee makers. The price demand function is x equals 600 minus 2p, and the cost function is c of x equals 10,000 plus 75x. Solve the price demand function for p and find its domain. So let's start with x equals 600 minus 2p. I'm going to move the 2p to the left. I'm going to move the x to the right, and then I'm going to divide everything by 2. So 600 divided by 2 is 300, and then 1x divided by 2 is 0.5x. Now, for the domain, clearly we know that x has to be greater than 0. And then the question is, what about what's sort of the highest value we could use for x? Well, that comes from knowing that hang on. That 300 minus 0.5x has to be greater than or equal to 0 because that's equal to the price. So then this would be 300 minus 0.5x. I'm going to go ahead and move that to the right side and then divide both things by 0.5. 300 divided by 0.5 is 600, and that's greater than or equal to x, which if I flip that around, I get x is less than or equal to 600. So the domain here is from 0 to 600. Question B, find the revenue function. So revenue is equal to the number of items times the price per item. So that would be x times 300 minus 0.5x. Multiply that out. That's 300x minus 0.5x squared. What is its domain? The revenue domain is inherited from the price domain, price demand domain. On the marginal revenue, evaluate the marginal revenue when selling 200 coffee makers. So marginal revenue is the derivative of the revenue function, so that would be 300 minus x, because 0.5 times 2 is 1, so it's just 1x. Evaluate the marginal revenue when x is equal to 200. So it would be 300 minus 200 is equal to 100. And the interpretation is at a production level of 200 coffee makers, revenue is increasing at $100 per coffee maker. Question D, find the profit function. So profit of x is equal to revenue of x minus c of x. So that would be 300x minus 0.5x squared minus 10,000 plus 75x. So it's going to be 300x minus 0.5x squared. Distribute the negative, so it's minus 10,000 minus 75x. Organize these in descending power order. So it's negative 0.5x squared plus 225x minus 10,000. Question E. Find the break-even points. There are two ways to do this. You either set revenue equal to cost and solve for x, or you set profit equal to 0. I'm going to use the second one. So it's negative 0.5 x squared plus 225x minus 10,000 is equal to 0. You may remember I don't like using these fractions in front of the x squared. So I'm going to multiply by a number on both sides to get rid of that. What number should I multiply by negative 0.5 to turn that into a 1? The answer is negative 2. So if I multiply by negative 2 on both sides, we end up with x squared minus 450x plus 20,000 is equal to 0. When you multiply an equation by a constant, you do not change what the answers will be. Both of those equations will have the same answer. We want to factor this. So we're going to have x and x. And then we need to find two numbers that multiply to give me 20,000 and add to give me 450. And it's 50 and 400. They're both negative. So x is equal to 50 and x is equal to 400. So the break-even points are 50 and 400. Question F. Find the local maximum profit and how many coffee makers need to be sold to get the maximum profit. What is the maximum profit possible? So we know that maximum profit occurs when the derivative is equal to 0. So I'm going to take the derivative of the profit function. We're going to get negative x plus 225. We're going to set that equal to 0. And then solve for x, and you get 225. So it's 225 coffee makers. And then what is the profit when you are making the maximum profit? Well, to find that, we'll just evaluate 225 in the profit function. And if I'm reading this right, looks like it's 15,312 and 50 cents. This number is found by evaluating 225 in the original profit function, not the derivative. Obviously, in the derivative, the answer is 0. Question G. The graph of the revenue and the cost have been graphed on the same grid. Fill in the boxes with either x or y values for the points listed as appropriate. So the bottom ones here are x values and the ones along the side are y values. Let's start with this point here. This is this point here. You can see it now. This is where the revenue and the cost intersect. When revenue is equal to cost, that's a break-even point. And the first break-even point was 50. Here is the other break-even point, and that was 400. This point on the right side is where the revenue function goes back to 0. Well, that is what happens when you run out of domain. So the largest value in the domain was 600. The revenue function starts at 0 and then ends up at 0 on the right side. So the maximum revenue must occur halfway in between 0 and 600, which is 300. You could also find this by setting the marginal revenue equal to 0, because up here, where we have a maximum, is where the revenue stops increasing and starts decreasing. How about these y values? Well, this first y value is where the cost function starts. And if you plug in 0 into the cost function, you get 10,000. And this last y value is the maximum revenue, which occurs when you're making 300 coffee makers. If you plug that into the original r function, your maximum revenue is $45,000. Question 7. Find the total profit for producing X cell phones. The total profit producing X cell phones is P of X is equal to negative 2x squared plus 800x minus 40,000. Find the exact profit from producing the 151st cell phone. So the exact profit would be P of 151 minus P of 150. And if you plug these numbers in, you get 35,198 minus 35,000, which is equal to $198. Question B, find the marginal profit in producing the 151st cell phone. So marginal profit, we need the derivative. Oops. We need the derivative. And that derivative would be negative 4x plus 800. Now, the marginal profit in producing the 151st cell phone uses the one before it as the basis for the increase. So you really want to find the derivative evaluated at 150. So it's negative 4 times 150 plus 800, which is $200. Again, the exact and the close should be very close to each other. C, find the marginal profit. So P bar of X is equal to P of X over X. So this would be negative 2x squared plus 800x minus 40,000 over X. That's all you had to do on that one. And D, find the average profit for producing 100 cell phones. So P bar of 100. You plug that in, and you actually get $200 even. So it worked out really good. Let's look at question 8. Find the equation of the line tangent to f of x is equal to 4x minus 8 over x at x equals 2. So we'll take the derivative here. The derivative of this is 4 plus 8 over x squared. We need the slope of the tangent line. So that's the derivative evaluated at the x value. So that would be 4 plus 8 over 2 squared. 2 squared is 4. 8 divided by 4 is 2. So 4 and 2 is 6. So this is equal to the slope. We need the actual point, so we take 2 and evaluate it in the original function. So that would be 4 times 2 minus 8 over 2. What is that? 8 minus 4, which is 4. So this means the point is 2 comma 4. So I have the slope and I have the point. And now I can use y equals mx plus b, or you can use the point slope formula. Use any of these little tools from algebra that you'd like. Here I'll use y equals mx plus b. So we get 4 is equal to the slope 6 times 2 plus b. So that's 4 equals 12 plus b. So b is equal to negative 8. So the equation is y equals 6x minus 8. Question B, find the equation of the line tangent to x over y plus y squared is equal to 7 at the point 6 comma 2. Well, here we need to find the derivative, and we have to do it implicitly because we have y's in the middle of our equation. So first I'm going to take the derivative of x over y. That's going to be a quotient. So it's the derivative of x is 1 times y unchanged minus the derivative of y prime, times the x unchanged divided by y squared plus the derivative of y squared, which is 2y, y prime, is equal to 0, the derivative of 7. Now to solve this for y prime, the first thing I'm going to do is I'm going to get rid of the denominator, and I'm going to do that by multiplying by y squared. When I multiply by y squared, it goes to this first grouping and cancels off the y squared on the bottom, so we get y minus xy prime, but then it does distribute to this second part, so we get 2y cubed, because it's y squared times the y, times y prime is equal to 0. From this, we do as before, we're going to move the term that doesn't have a y prime, we're going to move it to the right side. And so that's going to be a negative y over there. And then the other two terms, we're going to factor out y prime. So it's going to be negative x plus 2y cubed. And this gives me y prime equals negative y over negative x plus 2y cubed. So that is the derivative. Next, we can use that to find the slope of the tangent line using the evaluator. Remember, the point that we wanted to find it at was 6, 2. So this is now negative 2 over negative 6 plus 2 times 2 cubed. So it's negative 2 over 6 plus, looks like 16. And if you reduce that, you get negative 1/5. And so now we use y equals mx plus b again. And the y value was 2. The new slope value is 1/5. The x was 6, and we're solving for b. I'm going to multiply everything by 5 to get rid of the 5 in the denominator. So it's going to be 10 is equal to negative 6 plus 5b. So that's 16 is equal to 5b. So b is equal to 16 over 5. So the equation is y equals negative 1/5 x plus 16 over 5. Let's look at question 9. Given this function, find the critical values, create the sign chart, find where it's increasing and decreasing, and then find the local extrema. So first, let's take the derivative. So this would be 3x squared plus 18x minus 21. Set that equal to 0. I see that everything's a multiple of 3, so I'm going to factor out the 3. And we get 6, x, and then plus 7, and x minus 1. So there's no solution from the 3, nothing there, but these other two, because they have x's, give me solutions. So we get x equals negative 7 and x equals 1. Let's do the sign chart. We have negative 7 and 1. Those came from zeros of the derivative. And then if you plug in test values, you get positives, negatives, and positives. And so that tells me that f is increasing on negative infinity to negative 7, union 1 to infinity. So remember, a function is increasing when its derivative is positive. And then f is decreasing on negative 7 to 1. Remember, a function is decreasing when its derivative is negative. What about extrema? So f has a local minimum at x equals 1. The local minimum is where a function goes from decreasing to increasing. And then f has a local maximum at x equals -7. Again, this is where the function goes from increasing to decreasing. Let's look at f of x is equal to 3 times x to the 2/5 minus x to the 3/5. And then same directions as before. Find the critical values, do a sign chart, find increasing and decreasing in the local extrema. So first, let's take the derivative. So the derivative of 3x to the 2/5 would be 6/5 x to the -3/5 minus 3/5 x to the -2/5. So we want to find the critical values. There are two ways to have critical values. They are when the derivative is equal to 0 or when the derivative is undefined. Let's start by setting this equal to 0. Now, whenever you want to solve and it's equal to 0, you want to factor out the x with the least power. The x with the least power here is x to the -3/5 because -3/5 is smaller than -2/5. You want to also factor out some numbers if you can. I'm going to factor out 3/5 because I know that 6/5 is a multiple of 3/5. Speaking of which, what do you multiply by 3/5 to get 6/5? The answer is 2. The x to the 3/5 have all been factored out from this first term, so we move on to the next term. We have factored out the 3/5, and then we have x to the -2/5, and we want to factor out x to the -3/5 from that. So that would leave me with x to the -1/5. And you get that by just subtracting these powers. -2/5, let me write that up for you here. -2/5 minus -3/5 is +1/5. And you should also check it. If I multiply x to the -3/5 times x to the 1/5, do I in fact get x to the -2/5? Sure, because -3/5 plus 1/5 is -2/5. Well, this is still equal to 0. Now, set each factor equal to 0 and see what you get. So I'm going to do all of these so that you can see exactly what happens here. So we have 3/5 is equal to 0. X to the -3/5 is equal to 0 from here. And 2 minus x to the 1/5 is equal to 0. Well, clearly, the first one gives me nothing because that's a number equal to 0. There's not even a variable there. So, nothing from there. What about the second one? Well, the second one is really 1 over x to the 3/5 because of the negative exponent. That can't be equal to 0 either because there's no x's in the numerator. So nothing from there. Now what about this last guy? Well, let's solve him out. So we're going to have -x to the 1/5 is equal to -2. I'm going to multiply everything by a negative, so I get x to the 1/5 is equal to 2. And then to solve, when you have a power, fractional power like this, is you want to raise both sides to the reciprocal power so that you're forcing it to be a 1. Well, the reciprocal power, the reciprocal of 1/5 is 5. And so there we go. X to the 1/5 to the 5th power is x, and 2 to the 5th is 32. Now, it's not plus or minus because the power part of this exponent was odd. If this had been even, then you would have had to use plus or minus. But since it's an odd power, then you only get the one answer that it should be, which is positive because it came from a positive 2. Now, so that's one critical value. What about the other one? Well, if you look at f, right up here, you see that we have x with negative exponents. So the f is really, f prime rather, f prime is really 6/5 times 1 over x to the 3/5 minus 3/5 times 1 over x to the 2/5. And so clearly, if x is equal to 0, that means that f prime is undefined, because 0 to the 3/5 power is still 0, and you can't have 0 in the denominator. So your critical values are x equals 0 and 32. Now, with that information, we need to create the sign chart. So we're going to have 0 and 32. The 32 came from being a 0 of the derivative. The 0, however, came from being an undefined spot. So we put ND above that for not defined. Then if we do the signs here, we're going to get negatives on the left, positives in the middle, and negatives on the outside. And that tells us the following. F is increasing on 0 to 32. F is decreasing on negative infinity to 0 union 32 to infinity. What's 32? F has a local max at x equals 32. F has a local min at x equals 0. And that's it. That's how you do this test. Thanks for watching. Have a great day.